For those of you who were wanting the review on the video, here it is. Hopefully you use it and it helps you out. But either way, we are taking a test tomorrow. So I hope you guys get a chance to view it. Every single problem explained. So this is the formula they give you here. They tell you Nathan deposited $6,500. And in that account, it pays them 8% annual interest because it is continuously. This is why we have to use this formula. And it says, what is the balance after 4 years? So it has to use the formula. It tells you here what each one represents. So P is the principal. That means how much money he's investing, which is $6,500. The E is a constant. It stays there. The rate as a decimal. So that would be 0.08 times the number of years, which is 4. So you would take your calculator and you would enter this 6,500, the E, 0.08 times the 4. And remember, since we're talking about money, you would have to write two numbers after the decimal. So 8,951 with 33 cents. That right there would be how much money he would get after 4 years. Okay, so in problem 2, you would plug in the equation, make sure you put raised to the x power, and then here you would go to the graph, and actually see where the graph appears. Now remember, this is quadrant 1, 2, 3, and 4. So this graph only starts off here and it goes up, so it appears in these two quadrants, which will be quadrant 1 and quadrant 2. Now, for the next problem, that -1, because it's an outside exponent, needs to distribute to everything. So we're going to have 6 to the -1, e to the -3, 3 to the -1, e to the -7. Because we cannot have negative exponents here, they move to the top. Because I cannot have negative exponents on top, they would move to the bottom. So this here would become 3e to the +7 over 6e to the 3rd. Now, first thing you do is reduce your whole numbers. 3 over 6 reduces to a 1/2. Your exponents, because it's a division, you need to subtract. Now, what is 7 minus 3? Well, it is e to the 4th. Now, for the next problem, I actually gave you the answer, so I'm just going to cross it out, even though I'm going to have to rewrite this again. But let's say you had log base 2 of 7 times x. Because this here means multiplication, the rules of logarithmics are multiplication becomes addition. So in this case, I would have to do two separate logs, log of 2 of 7, plus, which really means multiplication, log of base 2x. This is you expanding that problem, because multiplication becomes addition. Number 5, they give you a model, and it's a y equals. This, you would have to go ahead and plug into your calculator. So I would go to my y equals, clear it, put 22,500.75 raised to the x power. Now the question is asking, where am I going, or when am I going to reach $5,300? So I would go here, go to my table, and 5,300 would be a little bit after 5 years. So then that right there would be your answer, 5 years. Number 6, number outside. That should tell you it's an exponent to everything inside. Inside we have two things, the 3 and the e, but the e has an exponent. When something has an exponent and there's an exponent outside, you end up multiplying those two. So this really becomes 3 to the 5th e 4x times the 5. Now 3 to the 5th, many of us make the careless mistake of putting 3 times 5, but it's really 3 raised to the 5th power, which is 243. So this here becomes 243 e to the 20x, because we need to multiply the 4 and the 5. The x really doesn't do anything, so that would be your answer. Number 7. We have covered log base b of y equals to x, and that would be written as b to the x is equal to y. Well, now they gave you y equals a to the x, which is really the same thing as this one, except instead of the b, they gave you an a. So now I have to write it as a logarithmic, which would be log, instead of the b, it's an a, y equals to x. This here would be the answer for that. Now, the next problem, number 8, it doesn't say it's an exponential, but it is. If it wouldn't say in your test, I would let you know if it's an exponential of power. We just need to enter the numbers that we have there. 12, 30, 75, 187, and so after you plug them in, because we know it's an exponential, we'll go to stat, calculate, and we'll go down to exponential and press enter, enter. So the exponential expression for this one, or function or rule, whatever we really want to call it, is 12 times 2.2 raised to the x power. This here would be the answer to that table. Now the next problem, can you please write log of 12 divided by log of 4 as a single logarithmic. Now you can't divide that. Remember, this is log of 12 with the base of 4. If I would give you this and I would ask you to plug it into the calculator, how would you do it? Like this. So now we're going from this to the way you would actually have it on paper. That's how it is. Number 10, rewrite it as a single logarithmic. This 3 should be the exponent to that. So I have log of 4x squared with a 3 outside. But that 3 distributes to everything inside, so it actually becomes log 4 to the third x 2 times 3. Now 4 to the third would be 64. 4 times 4 is 16, 16 times 4 is 64, 2 times 3, x to the 6. That's you writing it as one logarithmic. That's it. For number 11, because you have a log of 6 on both sides, you should be able to eliminate those. So, log of 6 eliminates, log of 6 eliminates. All you have to do is bring down your two equations that are left over. You would subtract 2x, subtract 2x, so I get 3x minus 9 equals to 6. I'm solving for x, so I need to add 9, so I get 3x is equal to 6 plus 9, which is 15. Divide both sides by 3, I get x is 5. Now, most of these questions are going to be multiple choice except for the bottom ones. So, in this problem it says make sure you round to 3 decimal places, show your work. This one you're trying to solve for x, x is in the exponent. So you should know, okay, I'm going to have to use a log to get rid of that 10. So let's get rid of that plus 3 first by subtracting 3, subtracting 3. Log to the x equals 27 minus 10 to the x equals to 24. The only way to get rid of this 10 is by putting a log there and a log there. I don't have to put a little number. Why? Because it's understood to be a 10 already. So this cancels already. So I get x equals log of 24. Now, that's correct, but when it's asking for them to round to the nearest 3 decimals, that means we need to plug it in. Excuse me. So we get this, and we get actually a 1.380, which equals 1.380. Now, if you want another quick example of what in the world is going on, let's say you had 7 to the x plus 2 equals to 25. What would you do? Subtract 2. 7 to the x equals to 23. How do you get rid of that 7? Log base 7, log base 7. So these guys cross out. X equals log base 7 of 23. So this goes a little bit back to number 9. How would you put this into the calculator? Log of 23 divided by log of 7. So we go to the calculator. Log of 23 divided by log of 7. My answer would be 1.611. There you go. Next problem, you see an E. What eliminates an E? The ln. But before you do that, E needs to stay as much alone as possible. So the first thing is get rid of that 4. Divide by 4, divide by 4. E to the 3x power equals 7 over 4. Now the only way to get rid of the E is by putting an ln on both sides. That causes that to get eliminated, but then I have 3x equals the ln of 7 over 4. But what is still in front of the x that we need to get rid of? The 3. So x equals ln of 7/4 divided by 3. That would be a 0.18. That's 6. Is followed by a 5, so that becomes a 7.